Okay, so we've already done the monohybrid cross, right? We started with the parentals, homozygous big P, homozygous little p. These were purple, these were white. Keep in mind, the letters that are used here aren't important. You know, you designate the big Y here for yellow, the big R here for round. It's capitalized because it's dominant, right? So in the heterozygous state like this, you still get the yellow color, you still get the round shape. Or in this case, you get the purple color, not the white color, when it's heterozygous. So to generate the F2 generation, right, these are going to be the genotypes of the F2 for a monohybrid. You bring this P here, big P, little p here, little p, big P here, little p goes in that square. These are the genotypes for the F2 offspring if you crossed two flowers with these two genotypes. So now we want to go and I want to explain the dihybrid, right? That means now instead of one phenotype, there are two. You can have a green or yellow P color, or you can have a round or wrinkled P shape. The yellow and round phenotypes are dominant. So just like when I did this cross and this cross, I generated heterozygous states, right? So when we cross these P's with these P's, it's just like, let's just ignore the R's for now. Then it's just like that big P, little p. Right now it's big Y, little y, little y. And that gives us big Y, little y, big Y, little y. Well, you don't have to do both of them, right? They're all the offspring from this will be this genotype, just like all the offspring from this are this genotype. So you see the similarities? Then if you just ignore the Y's and go, let's do RR with little r, then you would get all would be big R, little r. The F1 would be heterozygous. So to do a dihybrid heterozygous cross, right? That's what this is. This is heterozygous, this one's heterozygous, and so are these two. So it's pretty easy to see, you know, when you look at one, when you go from a 2N to a 1N state for the gametes, that's what you put here are the gametes. It's pretty easy to see you're going to either have big P or little p. When you have two, like this, the way you figure it out is you say the big Y with the big R, that gives you the big Y, big R gamete. These are 2N, these will be 1N. Then we put the big Y with the little r, that gives us that gamete. Then we put the little y with the big R, that gives us this gamete. And then we put the little y with a little r. Little y, little r. So these are the gametes, say for this guy would generate the same gametes because it's the same genotype. So to do the Punnett square, right, I just put these gametes here the way I'd written them. That's how I figured out all the combinations. Then we have big Y, big R down this, right, big Y, little r, and then little y, big R, and then little y, little r. I try to remember to put the little dash over the y, little y. Then to fill this out. Now there was I don't know if it's on the quiz anymore. There was a quiz in lab where I asked you to fill in these boxes, right? When you put in the letters, the Y's need to stay together and the R's need to stay together. Yep.
Now, Now, does the order matter?
I'm sorry?
Does the order where you like put the Y's matter?
No. I tend to keep it consistent, I always put the Y's in front of the R's. Matter of fact, I changed the PowerPoint because it had round yellow instead of yellow round. The more consistent I keep it, I try to do that on purpose. Consistency can just make it easier. If I just haphazardly did that, it would make it more confusing, at least in my opinion. I'm really tempted to do this with a big A, big B, crossed with little a, and little b, because it's easier sometimes to follow those letters than it is to follow these. But because the textbook uses these letters, which is the letters Mendel uses, I'll keep it like this. So big Y, big R, little y, oops. And then we got what, big, see, it's probably best to put the big Y first, but it's not necessary. Then we got two big R's. Normally you put so in this case, right, we have big Y, big R, little r. But if you look, see on here, on the PowerPoints, that's the way they'll keep them too. But that's pretty straightforward, right? Big Y, big R, little r, big Y, little r. And if you look, you'll start to see a pattern, right? If it's big Y, this will be yellow. That's a dominant phenotype. If it's little r, it'll be wrinkled, which is the recessive phenotype for the shape. Now this is a heterozygous. It'll be yellow and round because it's dominant. The only way you're going to see both recessive phenotypes is down here in this corner. Right? You're going to get the little y, and the little r. So you say at this point, 1/16, there's 16 squares, 1/16 of the offspring from a dihybrid cross will generate both recessive phenotypes. So how many give you all dominant phenotypes? Right, to have a dominant phenotype, you just have to have a big R and a big Y. This one would not be both dominants, right, because it has two little y's. Let's see, big Y, little r, little y, big R, little r. You have a little y, big R, little r, big Y, little r, and you have big Y, big R, little r. So what happens is these three, or this one, rather, has both recessive. And then all of these have little y's, right? That's one recessive, one dominant. That's three. These three are all similar. And then you have this one, and this one all have little r. That's a recessive, but they'll have one dominant. The rest of them have both dominant phenotypes. You have a 9:3:3:1 phenotypic ratio. One of them has both recessive. 9 of the squares have both dominant phenotypes. 3 of them have one dominant, one recessive, and 3 of them have the other dominant, other recessive. okay? So I just wanted to redo this and give you a better, and have a nice video